Welcome back, Ordinary General Annuities, part two. Here we'll talk about payments, number of payments, and calculating the interest rate of the annuity. So three little components here. Do some practice problems. The basics are very similar, are virtually exactly the same as for ordinary simple annuities. Again, only difference is the payments per year is different than the compounding periods per year, aka P over Y and C over Y are different. Okay, let's talk about payments. Question number 5. How much must be deposited, at the end of each quarter? So talking about a payment amount at a regular interval for 12 years to accumulate to $14,000. So that's future tense, we're accumulating, so future value at 8% compounded monthly. Okay, so we have ourselves an annuity. So we have our N, we have our I, we have our present value, we have our payment. Now we're saying how much must be deposited at the end of each quarter, so that's telling us it's that payment is what we want to find. Future value, P over Y, and C over Y. So how many payments do we make each quarter? So that's 4 of those payments per year for 12 years. So 4 times 12 is 48 with an interest rate of 8% compounded monthly. So that means there's 12 of them. Present value, no, nothing talking about any lump sum payments at the beginning, so 0. Future value, well, we want to end up with $14,000. Okay. Now, this payment is technically going to be a negative because it's money we're putting in. So future value is going to have a different sign. Okay, because we're going to accumulate 2. And eventually at the end of this 12 years, we're going to get the $14,000. Okay. So after that, plug stuff in, and we get a payment of equal to $175.80. Now, when you're answering this and filling it in, there won't be a positive or a negative on there. That, you may have noticed, in a lot of cases, we drop. That positive, negative is all relative, right? My payment of $175.80 is somebody's receipt of $175.80. So when we just talk about payments, those signs drop off in the discussion so that people can understand what it is that we're talking about. Question number 6. Very applied kind of question. Jordan bought a car priced at $11,300 for 15% down and equal monthly payments for 4 years. If interest is 8% compounded semi-annually, what is the size of the monthly payment? First off, the monthly payment is based on how much you borrow. Not how much the car cost, but how much did you borrow. That is our key metric here. So I think question number 6. First thing we need to know is how much do we borrow. So we got $11,300 for the car, and that down payment is like a discount. We've seen this before. And so 1 minus that down payment, and that gives us $9,605. That's how much we actually borrowed. So now we flow in, find the payment, again, based on actual borrowing. It's an annuity, so we have all our basic parameters and key pieces of information for that annuity. So, N, how many payments are we making on this thing? 4 years, monthly payments, 4 times 12, 48 of those. Interest rate, 8%, compounded semi-annually, and of course those payments are 12 per year. What else do we know? How much do we borrow? Hey, we just figured that out. $9,605. That's positive because it's money flowing to us. Let's just go. Payment is what we want to know. Future value. Hey, every lender hopes that you do this one thing, that you pay off the whole loan, or alternatively, no big lump sum payment at the end of all this. Okay, So now we just plug in our regular parameters as we typically do, and we will get that payment come spinning out at us at $233.90. There we go. All set, done, game, set, match. And number of payments is a tricky, not hard, tricky, not hard in the sense that the calculations are hard. The calculations are the same as every other calculation we've had, right? The tricky part in this is, what does N represent? N represents the number of payments. But sometimes we can use that to find how long the term of this annuity is. Okay? And it's when we take that number of payments and convert it to how long the annuity is, the term of the annuity, that's where there's often a misstep. And I'll illustrate that misstep at the very end of this problem. Okay? Question number 7. For how many years? Okay, so how many years? So we're looking for the term, right? Okay. We can find N, the number of payments, and then use that to find the term. There's one more little step. We need to take that N, the number of payments, and to find the length of time. Okay. Common mistake, and I ask this question on many final exams, is to forget that last little step. It probably gets forgotten more often than it gets remembered. Actually, I know for sure it gets forgotten more often than it gets remembered. Okay. So, how many years? Makes payments on the $48,000 you borrowed to start his machine shop. He makes payments of $9,400. So, an equal amount at the end of every quarter. Interest rate is 8.08%. So we have ourselves an annuity because we have regular payments at a regular interval. Okay. So we set up all our our standard annuity stuff. N is what we want. Short term, N is what we want. Then we're going to use that in one little extra step, okay? So far we've kind of, hey, it came out of the calculator, I write it down, I'm done, boom, 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 off I go. This one teeny tiny little step to go before we can hit that spot. We do make payments every 3 months, so that's 4 times per year. Interest rate of 8.08%, compounded semi-annually, so that's 2 compoundings per year. We did borrow $48,000. We got that dough, so that's positive. $9,400 payments, that's going away from us. That's a negative. Future value, any lump sum payment, no, does not appear that there is. And so we're off to find N. Okay, so first step, we find N. Okay. So we find N, and always verify this, and we get 5.44 payments. Now, what does that represent? Okay, that represents 5 full payments and 1 partial payment, right? 1 partial payment of 0.44 of our regular payment. Okay, total of 6 payments. And again, 5 full payments, 1 partial payment. When does that partial payment happen? It happens at the end of the next quarter. So really, the term is the 5 plus the 1 is the 6 quarters. Okay. Or call it what you want, converted 1.5 years, 18 months, whatever, right? Okay. The key thing that gets missed is people, 5.44. I times that by so I got 5.44 quarters. Well, no, right? The fact that you make a partial payment at the very end of the term doesn't mean you don't make the payment early. Remember, we got to make those payments at equal intervals, right? We make them every quarter. We don't make this one payment partway through the quarter. We don't make partway through the quarter payments. We make end of the quarter payments. And when does that 0.44 of a payment happen? End of the 6th quarter. Because I make my regular full payments at the end of 5 quarters. And then I got this little remainder partial payment. I make that at the end of the 6th quarter. Because payments only happen at the end of the quarter. Total of 6 quarters. That's 1.5 years, 18 months, and we're off. But boy, that gets missed. That by 4.44, it messes folks up. Okay, let's do another question 8 here. Mr. Musk accumulated $220,000 in an RSP, converted the RSP into a registered retirement investment fund, which is a common thing that people do. They have a lump sum in an RSP, then they convert it into a kind of, it's RRIF is an annuity, typically offered by insurance companies. So there's an insurance component in there should you die and stuff like that. Okay. Start to withdraw $2,500 at the end of every 3 months from the fund. Okay. So that's standard thing. There's annuity. A bunch of rules as to how much you have to withdraw and stuff like that, but we won't get into that here. If interest is 6.75% compounded monthly, for how long can Mr. Musk make withdrawals? Okay. So we have ourselves our annuity. And again, same caveats as before, right? We're going to find that end, but it's not the end of the story. End is just the beginning. That's actually the middle, but it doesn't sound as cool. End is just the middle. There's just no panache to that. Okay. So end is what we want. What do we get? Interest rate we get 6.75%. Compounded monthly. So there's 12 of those. How often do we get paid here? Every 3 months. So that's 4 times per year. You accumulate it in an RSP. He converts the RSP into a RIF. So we're talking about the RIF here, or the RRIF. So we start off with the $220,000. Okay. Now that is a negative. And that's a kind of an intuitive thing because he's got the money. He's got the 220 grand. Hey, woo, big bundle of cash. Government is going to kind of try and swoop in on and take the big lump sum of that. And so he puts it into the RIF. So he's buying an annuity. Okay, so it's a negative. Does that avoid the tax, guys? Payments, what does he get? He gets $7,500. That's positive, right? Because that's going to be money coming towards him. Does he get a lump sum, at the end of some period? He does not. And we're all set. Okay. So we'll find our N. And that N will be 40.93. So he gets 40 full payments plus 1 partial payments. So that means he gets to make, or he makes withdrawals for 41 periods. And in this case, 41 periods represents 41 quarters, 3 months per quarter. 41 times 3 gets us 123 months. So he can make withdrawals for 41 quarters, or if you prefer to convert it into months, 123 months. Next segment, calculating interest. Anytime we're calculating interest, there's 2 interest calculations that we could do. In question 9, you see the first one. That's just finding the nominal rate. That is the rate that our calculator spits out. Okay, so when you see the I on your calculator, that is finding the nominal rate. As you can see in question number 10, we take that a little step further and find not only the nominal rate, but the effective annual rate. Now, in question 9, the effective annual rate is of limited meaning because the interest is compounded annually. But those are the 2 types of interest rates that we can calculate. Really easy that when the question asks for an effective annual rate, like it does in question 10, you find the nominal and you forget that one little tiny step. So beware of that. Question 9, car valued $11,400 can be purchased for 10% down and monthly payments of $286.21 for 3.5 years. What is the nominal interest rate compounded annually? So we have an annuity, regular payments over a regular time interval. Question 9. And so we have our N, we have our I, amount we borrowed, our payments, our future value, or any lump sum payment we have to pay at the end, payments per year, and our compoundings per year. So we see that 3.5 years, and we go 3.5 times by 12 because of their monthly payments, and we get 42 payments in total for this particular loan. I is what we're trying to find, the nominal rate. Those payments are 12 per month. And it does say that interest is compounded annually, so I do have that one down there on the C over Y. Now, how much did we borrow? Well, we borrowed $11,400. Right, and times it by 0.9 because we financed 90%. If you put 10% down, you finance the 90%, and that will give us a number of $10,260 that we actually finance. The payment is a negative $286.21, money flowing from us, and of course no lump sum payments, or the borrower hopes we pay this thing off completely by the end of the term of the loan. And so we now punch this through, and answer comes spinning out very quickly, around 9.5%. Okay. The old days when I was first doing these calculations, used to be able to go and run, grab a tea, grab a coffee, grab a Coke, and it was just like spinning because it has to do a little bit of algorithm trial and error stuff to try to come up with the interest rates really quickly because there's no really closed form, or there's no formula for solving this. All right, question 9, done. On to question number 10. All right, question 10. Question 10, our last question of this particular unit. A vacation property valued at $350,000 was bought for 15 payments of $32,000 due at the end of every 6 months. What nominal annual rate of interest compounded monthly was charged? What was the effective interest rate? Ooh, cool. Little wrinkle on this one. So we do want the nominal interest rate, just like we found with question number 9, and then we're going to take it a step further and find the effective rate of interest. We did the effective rate of interest in the ordinary simple annuities unit. Okay, so I'll just refresh for you the commands necessary for that, and then I'll give you the answer, and then I encourage you to work it out, because finding the effective rate of interest is a very realistic problem. Okay, so we have our N, our I, our PV, our payments, future value, payments per year, compounds per year. So standard stuff. 15 payments, and those payments are every 6 months, so there's 2 payments per year. We have an interest rate that we don't know, that we're going to find, but the compounding period was 12 per year. And what else do we need to know? We need to know the present value. How much did we borrow? It appears that we did not put down a down payment here. So we have $350,000 positive because we got the money from our financial institution in order to buy the house. Payments are $32,000 every 6 months. So that's money flowing away from us, hence the negative number. And no mention of a big lump sum payment at the end of this particular loan. So that is the big goose egg. So same as we did before, we run through and we get I. And again, always verify, but I got 8.325%. Now they want the effective annual rate, because this is 8.325% compounded. So the nominal interest rate is actually technically 8.325% compounded monthly. We want the equivalent, the effective interest rate, or the equivalent annual rate, or the annualized percentage rate, APR. That is essentially a compounded annual rate. So we wanted this compounded annual equivalent. Now we learned 2 functions depending on which calculator you used. We had the iConv, so if you're working with the BA2 Plus, you'll see up a little iConv above the number 2 on your calculator, and we worked with the conversion periods there. If you're working with the TI-83 or 84, you'll go into apps and go into finance, and you'll look for EFF. It's in the neighborhood of our good friend days between dates, okay? And we use the EFF. Now, both of them require as two arguments. Is the first argument they will require is the nominal interest rate itself, okay? And it's expressed as an interest rate, so don't decimalize it. And then as the second argument, both will require the number of compounding periods per year, which in this case is 12. Okay, you'll run that through, and you'll get an ultimate answer of 8.65%. Okay, we're expecting an answer to be higher because, you know, more compoundings means more times that interest is converted into principal, and so with that, we would expect a compounded annually rate, which is essentially what EFF is, to be a little bit higher than a rate that is compounded more frequently than annually. Okay? And that wraps up annuities. Awesome stuff.